All right. Good morning, everybody. Thank you so much for joining the Department of Water Resources Sustainable Groundwater Management Office today for our week of webinars. My name is Paul Goslin, and I'm the Deputy Director of Sustainable Groundwater Management at the Department of Water Resources. This week of public webinars was targeted to provide specific information for all interested parties and different audiences each day. We hope you've joined us for other webinars this week if they were of interest to you. Recordings of the webinars will be posted on our webpage in the coming days. So if you missed previous webinars or have to leave this one early, you'll be able to go back and view them. Today's public webinar is on accessing groundwater data and tools. I want to take a moment up front to recognize that the work you are all doing to manage groundwater sustainably is paving the way for a new era of groundwater management, where locals and their communities are charting what sustainable groundwater management looks like as we move forward into the future. This work in front of us, the collective groundwater community, is critically important, since groundwater has served as a resource during prior droughts and during this current drought. Nearly 85% of Californians rely on groundwater for some portion of their water supply, and over 1.5 million Californians rely on domestic wells for drinking water. It is critically important that we have good data and tools to help us understand the groundwater resources beneath our feet. Improved data and understanding will help us improve our management of this important resource. So again, thank you for your dedication to this important work. We've set up the Teams platform today where you can either join from a computer device or call in. There's an opportunity in Teams to have closed captioning. And we have a chat function open so you can provide questions and comments throughout the presentation to ask questions or provide comments. Our staff has incorporated time for us to have a good dialogue today, so there should be good time and good conversation. With that, I'd like to take a moment to introduce the staff that will be hosting the public webinar today. From DWR's SIGMO staff, we have Stephen Springhorn, Shane Edmonds, Ben Breezing, Tim Godwin, and Melissa Sparks Krantz. And from the State Water Resources Control Board, we have Anthony Woolitz, Emily Houlihan, and Aaron Button. So without any further ado, I'll turn it over to Stephen to kick off the program today. Thank you.
All right, thank you, Paul, and good morning, everyone. Thank you very much for attending this webinar. We're really excited to share the information that we have that the team's going to present today. And I just wanted to go through a quick overview of what the plan and the lineup is for today, and then go through some instructions on, again, as Paul mentioned, how to fully participate in this webinar. So the plan for today is to really start from the ground up, if you will, from the foundation of making sure data is accessible and also open, to then highlighting some of the applications that are used and connected to that open data platform, and then finish out with some applications around turning groundwater information or data into information and knowledge. So with that, we're going to start with the first session on groundwater data and resources, and Ben Breezing, who leads our SIGMA data unit, is going to go through the department's open data activities, infrastructure, as well as talk about some existing and upcoming data sets. We'll have a short Q&A, about 5 minutes after that. Then Ben's going to continue to present on one of our groundwater applications that's been out there for a while, but the team has been making some recent enhancements to, and that's the SIGMA Data Viewer. We'll pause after that for another short 5-minute Q&A. And then we'll wrap up with the last segment, which Brett Wyckoff and Shane Edmonds, who are two of the co-project managers for California's Groundwater Bulletin 118, are going to showcase an upcoming California's Groundwater Live application that we're really excited about. And then we'll finish with the remainder of our time with a final question and answer session. And again, as mentioned, please continue to put comments or questions in the chat, and we'll queue those up, and our team will be working through those at the various Q&A sessions. So really quickly, wanted to, again, just start with some instructions on how to participate today. So there are two ways to participate in the webinar today. The first is by listening through your computer's audio using your speakers or headsets when you join via the Teams link on your computer or mobile app. The second is by calling in on your computer or phone. To call in, dial the phone number from your device and provide the conference ID shown here on the screen. And then all participants' microphones will be muted and video will be disabled. And then please note that today's webinar is being recorded, and a copy of the recording will be made publicly available on our webpage following the meeting. So you'll have access to that. Then for the submittal of questions today, the first way to do that, there's two ways. The first way is to send your question in the Teams chat. So you go to your Teams dashboard, and the upper ribbon, you'll see a conversation icon, a chat icon. You click on that, and that's going to open up the Teams chat, and you can just put your chat in there and or your question in there, and we'll be monitoring that. The other way is to submit your question if you're not on Teams, to submit your question through our Sigma email, which is sgmps@water.ca.gov. Again, sgmps@water.ca.gov. And our team will read questions aloud, and then we'll be answering those amongst the team, the panel members from the department, as well as the state board that are here today. And then if you see a question or comment that you agree with, please note that in the chat box. You can use thumbs up or different icons to interact and participate in the meeting today. And then if you have input on the use of Teams platform or today's meeting, please also provide that feedback to us on this webinar to that same sgmps@water.ca.gov. Your feedback's really important to us. So if you do have some ideas on how to improve future webinars, please let us know. All right, so with that, I wanted to start with a quick overview of the groundwater landscape, groundwater data landscape in California. And I think as many of you on the call today are very familiar that the state of California is highly variable and very large in its geographic scale across all the 515 groundwater basins, which within those basins, there's a roughly 20 million acre feet of groundwater pumped. The vast majority of the population of California in those groundwater basins, and almost 8 million irrigated acres, as well as a lot of diverse environmental assets across the state. So, and all of that, there's a lot of data related to that. And then if we look at the 3D block, this is a figure from our California's Groundwater Bulletin 118 document. It just shows all of the different aspects of water management, not just groundwater management, but we know that surface water and groundwater are connected. And there's just so many different activities that are happening in California's water management from the local level, from the state level to the federal level. And all of those activities generate a lot of information and data, and also necessitate access to timely information. And so that's really the focus of today's discussion, is to show what we're doing at the department. There's a lot of other activities, but we're really focusing on what we're doing at the department. Also, we're coordinating with the state board, and we have our colleagues from the state board on the call as well, and seeing how we're trying to manage this fire hose of information, existing information, but also this new information that's coming in through the Sustainable Groundwater Management Act, or SGMA. So looking at some ways, sort of more of the groundwater data management landscape, is there's some key areas that we're really targeting to understand how things work, and then work on ways to make this more efficient and get feedback and develop applications or tools for accessing the information. And the first step is the data sources or the submitters, or who submits water or groundwater related data in California. And so we know that there's over 260 groundwater sustainability agencies, many groundwater sustainability plans, more coming. And so SGMA really is a engine of generating a lot of new information and compilation of existing information. There's existing programs on groundwater levels that there's thousands of monitoring stations, millions of records of groundwater level measurements. And then we also have the well infrastructure in the state of California, the groundwater infrastructure, which is roughly the 1 million well completion reports that are submitted by drillers that provide a lot of water or source and water to communities, to agriculture, and the rest of Californians. And then we do have a number of SGMA data sets that have been generated more recently, and Ben will talk more about that. As well as mentioned, we have our colleagues from the State Board here, and there's a variety of different water quality programs and data generated or submitted through that. And the list goes on. And so it really does show the magnitude of the information in California. And really that then gets to how does that get managed or combined or compiled into a source that people can easily access and connect to. And so that's where open data, it really plays a key role. And there's been a lot of work within the department through the work related to the Open and Transparent Water Data Act, or AB 1755, from a few years ago. There's been a lot of work across the state to really improve how data is managed, how it's put into an open data and transparent fashion. And that starts at the federal government with data.gov, at the state of California overall at data.ca.gov, and then within our agency, the California Natural Resources Agency, which the Department of Water Resources within, we have a data.cnra.ca.gov. And so Ben will talk more about these open data assets and opportunities or resources, but it really is an important foundational step for us, all of us, to have authoritative information in one spot that has metadata, so people understand the information that's there and how they might access. So then off of that open data platform or ecosystem, there's a lot of connections that can happen to applications that are built on top of those open data platforms to add more context. And so one of those that Ben will talk about later in the presentation today is the SGMA Data Viewer. And that is highly leveraging the open data environment. And so the data that Ben will show you is really, it resides in the open data pool, if you will. And then when that gets updated, as new information comes in, it automatically updates the SGMA Data Viewer. And so it's building this system of more automated, accessible, and timely information to use. And so we'll touch on the SGMA Data Viewer today. Also, the upcoming California's Groundwater Live leverages our open data structure architecture. And there's a whole host of other applications across the department, across the water board, across the state. And it really is important that as much as we can, a lot of these applications are pointing back to authoritative, open and transparent sources so we can get at actionable information. And that really gets to this pyramid of the foundation of open data, turning that into information, which is the SGMA Data Viewer in today's webinar example, and then turning that into knowledge, which Shane Edmonds and Brett Wyckoff will talk about, our California's Groundwater Live, which really tries to take the groundwater information and turn it into more information or knowledge. We haven't solved the tough use case of developing wisdom, but that really is where you all come in as the users of this information to use the information to then do and take action for what needs to be done, whether it's for the drought and thickness. It's raining today, which is a great thing, but there's a lot of information needed to take these critical actions in our state and for different programs like our SIGMA program, both at the state and local level, as well as the SAFER program, and there's many others. And so then the cycle really repeats. So when those actions are taken based on the data that's available, that generates data. So then that data gets ingested again, and then the cycle repeats over and over again to where ideally we're building off of the shoulders of what has come before us and not having to recreate the same thing over and over again. So that's really the vision. You'll see examples of that today in the presentations of where we're going. We're not there yet by any means, and so providing feedback is absolutely critical. And so we're really happy to be having this discussion today, answering as many questions as we can, and moving forward, trying to improve our data access in California. So with that, we'll transition over to Ben Brezing, and he will pick it up from here and talk about our open data assets and other resources. Thank you.
Thanks, Stephen, for the introduction. And as Stephen mentioned, we'll first start off with kind of the fundamental data platforms, sharing platforms that we have, and talk about a few key data sets as an example to show how we serve up these data, but also to highlight some of the data sets that we find specifically or particularly useful. If you can, yeah, great. So I'll first give a very brief overview just of the CNRA Open Data Platform. As Stephen mentioned, it's a federated platform that is connected with the state's Open Data Platform. Then I'll quickly go over our DWR GIS Atlas, which is our server for public GIS services that we'll later show that we're using ourselves for our web applications that are public. Those same services are available for anyone to use in their GIS desktop applications or in your own online tools. And then we'll go over a few key data sets and use those as examples for how the tabular data is served up on Open Data and how we link to GIS services. And then I'll nerd out a little bit on some of the frequently asked questions on how to use these services in GIS software, and hopefully that won't be too dry, that topic. But then we'll move on to the more fun stuff, to the knowledge and wisdom part. So here's just a screenshot of the landing page of our Open Data portal that we've been leveraging to really push out in bulk our data sets to help you get access to statewide data sets and to help us not spending our resources on responding to requests for data sets if we can just make them available online. So more and more you'll see that additional data sets will pop up on this platform. And they're organized by data sets and by topics. So you see that search field down here. And so any of these data sets then will have additional resources like data tables and links to GIS services. And if you move on to the next page, it's probably the visually most thrilling screenshot that you'll see today. This is kind of the landing page of our GIS server. And I remember when I first ended up browsing to a GIS server and I had no idea what I was looking at. But if you're not a GIS user, just know that this is a directory of our services that are organized by category, and then within each category, I show an example of going into the geoscientific topic. You'll see an alphabetical list of all the map and feature services. Don't worry about the difference between feature and map services. But those are, again, the services that you can bring into your GIS software and use the same live data sets that we're looking at for our applications. And often we get the question, can I get a shapefile to download? And we do make that available for some of our data sets. But I do want to point out that the beauty of these services are that you can just use them just like any downloadable GIS file, and you don't have to worry about those services being outdated. So as much as you can, try to leverage these services so that you're always in sync with others that are referring to the same sources. So can you move? Yep, thank you. And again, going right into pretty seemingly dry content, but here are just a few screenshots how to connect to the server with your JS desktop software. You first have to, step one is to connect to the server. The address is provided up here. And once you have that server connection, then you can access any of these layers just like you would with local GIS files. Only, again, those are the live services. You'll see once you're connected to the server, you'll see a folder structure that is the same folder structure that we looked at before at the browser. And then if you go into any of these folders, you see a full list of all these services, and you can connect can connect to anyone, and it'll pop up in your JS software, and you're good to go to do your analyses. Can you next? Thank you. So now we'll go into some of the data sets that we have on the Open Data page. Just quickly highlight some of the different resources as well as the GIS services that we list. One of our key data sets obviously is groundwater level measurement. And as highlighted here, so just an overview, this is what a data set usually looks like on Open Data. It usually has a title, a description, and then it provides a list of the different data and resources that we then list below. And further down, if you scroll down on the actual page, you'll see also a program contact info and yes, additional metadata. And then if you click on any of these resources, I think the next slide shows an example, for example, of the measurements table. So we usually provide a table preview. And you see this data set has a few million records. And already in this preview, you can filter this data set down, for example, to site codes or to stations, groundwater level measurement stations. And also highlighted here is that you can that you can download the whole data set. And there's a link to the data API, and the API stands for Application Programming Interface. And that's basically the way how our applications, and really also the any software that pulls data from these resources, communicates with a data set. So for us, it's been really nice to upload our data sets in bulk and then automatically have a API in the background that our applications can connect to and others as well. Then on the right, there's a different resource of that data set, which is in this case a link to the GIS service of all these groundwater level stations. And it shows the statewide coverage, tens of thousands of stations that historically have been monitored, but also the currently monitored stations. And one thing that was highlighted on the previous screen is that this data set includes data collected by various DWR programs, and it also includes all the incoming data through the CASGIM program as well as through the Sigma monitoring network module. So it's kind of a one-stop shop for periodic groundwater measurements. And next slide. Not sure, Stephen, if you can move on to the next slide or.
Hey, Ben, this is Stephen. I'm on the well completion report slide now. Can you see that?
Oh, I can't, but luckily, oh, now I can. There's some lag from my end. Thank you. So another data set is the well completion reports data set. Water well drillers in the state of California have to submit a well completion report to our department whenever a well is constructed, modified, or destroyed. And for decades, DWR has been receiving these records initially in paper form all the way through 2015. And then in 2015, end of 2015, our online system for well completion reports became online. Since then, all the reports are submitted electronically. And what you see on the right are all the data tables that are being populated from the digital submittals. And also further below, you see links to the PDFs of scanned legacy reports. the beauty of now the online submittals with the OSCAR system are that you, if you really want to do some data mining, you can skip looking through the PDFs and you can go straight into any of these data tables to look up the geologic log information, for example, of any of the wells that have been submitted electronically. Next slide. And I apologize for the PowerPoint presentation. My goal was to do a live demo that we could have also dove into some of these resources. I may be able to do that during the Q&A session, but my connection is not great, so we went for the more robust PowerPoint presentation route. So another resource or another data set is of incoming dry well reports. Stephen, you may want to provide some context, but just want to highlight that the incoming reports are updated daily on our open data page on the URL displayed on the screen. It'll soon be rebranded and it'll have a snappier title. But Stephen, if you want to chime in quickly, give some context here.
Yeah, thank you, Ben. Yeah, so as Ben mentioned, this is our dry well reports. These are voluntary submittals across the state. And this system has been in place since the previous 2012 to 2016 drought. However, we have received feedback and know that these are very important information and an important topic. And so we are trying to enhance this dry well reporting system and improve the ability for reporters to have the outages notified to local and state officials, and then ideally have the time to get assistance for those dry wells to reduce that time frame between a dry well submittal or outage to assistance at the local level. So we are looking to, in the middle of updating this system, and we'll have an updated system out in the coming weeks.
Great, thanks. And we'll later also show in the application part of this presentation how we ingest any of these services and use these data sets from as much as we can from the Open Data Portal in our applications in the Sigma Data Viewer as an example, as well as in CalGroundwater Live. Another key data set that we've been investing in making public too for everyone to use is the statewide INSA subsidence data set. So this is satellite-based measurements of vertical ground surface displacement or subsidence. And this data set uses data from the European Space Agency Sentinel satellites. Coverage began late 2014, and for our purposes, we incorporated data starting from January 2015, where coverage was already available. Statewide coverage didn't kick in until June of 2015. And from that, we've been providing or creating a total displacement time series raster images, as well as annual rate raster images. And I think some of the future slides will go into more detail, but here also on this data set, importantly, we have the data reports, an accuracy report, tutorial videos on how to interact with the data on the Sigma Data Viewer. We'll show that later. And then also the GIS services. If you can go to the next slide. One difference with this data set to the other map and feature services that we showed earlier is that the other services are predominantly vector services. And the INSA data is a continuous raster image data set. So there's a different GIS image server that you want to connect to. Once you connect to it, similar to what I've shown before, you'll have access to all the different time steps of the total subsidence since 2015 June, as well as the annual subsidence rate rasters. Those rasters are provided in monthly time steps. The raw data comes in higher frequency, but we've downsampled it to monthly time steps to find a trade-off between having high enough of a sample frequency and not ending up with too many time steps to manage. And can you move on to the next page? So that's a topic that often comes up, and I want to make sure that these services are fully utilized too, because these services, when you bring them into a GIS software or also to some online map viewer, they come through with a default symbology that we've assigned, which is serves kind of a statewide overview purpose. But if you want to dial into your area of interest, you might want to reassign a custom symbology. And you also want to make sure that you don't just look at the image values, the RGB values that come through by default. So how to expose the raw pixel image values is you go into the properties tab of this layer. In this case, I'm using ArcMap as an example, and under the processing template, you just have to switch from classified to none. And then what happens on that next grayscale image is that you actually get the true pixel values that represent vertical displacement in feet for that time step of the specific service that you pulled in. And once you use the service and the raw pixel values, then you can reassign again a custom symbology that serves your particular needs. The next slide is the nerdiest slide that I'll confront you with. And that really highlights that while we have a separate image service for each separate time step, we also have mosaic image services that combine all the time steps into a single service. And you can run a query, and on this screenshot, I just show how for one particular lat-long pair, and on the bottom is the actual query, you can ask, what is the subsidence over all these time steps? What is the time series for that location? And then when you hit that API, so it's not intended necessarily to be human readable, but this is what your GIS application would read, or your custom query to find out what the full displacement time series would be for that point. So that list of data points goes on and on and on. Just wanted to highlight that you don't have to click through all these different image services to get the value for each point. You can just use those mosaic services to get the full time series data. Okay, so moving on to another data set, and I'll keep things lighter now because again, the GIS services, the use of those and the access to the tabular data is common between those data sets. So it's really a consistent experience on our open data platform. Another data set I just want to highlight is the statewide crop mapping data set that we have for 2018, 2016, and 2014. On the open data platform, and we again link to the GIS map services and feature services. And in this case, we're also making the GIS shapefile available for download, as well as a geodatabase format, and then also provide the metadata documents. And I think the last example of a data set, well, that's upcoming, of our ongoing airborne electromagnetic surveys that are currently ongoing, will be statewide throughout high and medium priority groundwater basins where data collection is feasible. And these data that are being collected and the derived processed data results will be made available on the CNIA open data platform, as well as with all supporting data that have been digitized. In addition to making all the data available on open data, we're also currently developing 2D and 3D map viewers, and also working with our consultants and ESRI to see what will be possible and what we can maintain as viewers. And then for more program information, I'm providing the link below too. So that was, I think, all for the overview of the open data platform, and again our GIS atlas, and a few examples of the data sets and how they're served up.
All right, thank you, Ben. So now we're going to pause here for a Q&A session. I think there's a couple of questions that have come in, and just a quick reminder how to submit a question during today's webinar is you can use the chat feature within Microsoft Teams and put your question into the chat, or email us at sgmps@water.ca.gov. All right, so Ben just went through a deep dive into the whole architecture of open data, the data sets that we have, and now we're going to be transitioning to how that architecture and open data platform is then used to turn into applications for a particular purpose like Sigma or groundwater data exploration. But before we go there, Tim Godwin from our team is is coordinating the questions, and we want to check in with Tim.
Sure. Yeah. Thanks, Stephen. Thanks, Ben. So we've had a single question come in via chat, and it is basically where they're asking if there will be any discussion around data connections to DWR's Excella data and possibilities around syncing local agency Excella data with the state.
Okay, so I can give that a shot. Excella is a software platform that is used by many local agencies for permitting, and what the department uses Excella for is for the online system for well completion reports. We will probably transition the online system for well completion reports to a new platform in the coming years, and with that we will probably leave the Excella platform. While the online system for well completion reports has hugely increased the data quality and consistency, and also the availability of the data, it's we're still looking at making improvements to get exactly to the question to improve data access and data sharing between agencies. What I showed earlier, the data set on open data of all the data that we have in the online system for well completion reports is an export from the Excella database that gets updated on open data weekly. And again, that's the statewide data set. If that is not sufficient, any public agency member can request access to the backend of Excella to have a live access to this data set where appropriate.
Great. Thank you, Ben. That's the extent of our questions thus far. We can forward.
All right, thank you, Tim and Ben. So I just put up a poll. This is another way we want to just engage with all of you on the call today, is if you could fill out the poll. It's just a quick question on how you interact or use groundwater data, from more general purpose, a technical user, very technical users, or you don't currently use groundwater data, which we're hoping to change that with some of the tools that we're developing. But you can select multiple entries here and submit your vote, and then that'll help us just identify who we have on the call, and then we'll sprinkle in a few other polls as we're going at each Q&A session. So thank you for your responses. And then that poll can show up, or it does show up in the meeting chat. So if you want to go look at it again. All right. Okay, so we can continue forward. And the next topic, again, is an example of one of our flagship data viewers for our Sustainable Groundwater Management Office. And this has been out for some time now, but Ben and the team have been updating it based on feedback and new data sets that are available, and coordinating with our colleagues from the board, and some of the key data leaders from the board are here on the call as well. So Ben, you want to jump into the data viewer?
Sure, and this overview slide is good, and then maybe we can dare to switch to a live presentation, and then if things aren't working well, then we can go back to the PowerPoint. But what you see is the landing page of the Sigma Data Viewer. The Sigma Data Viewer was developed as part and is being maintained as part of DW's technical assistance to GSAs and other agencies and the general public. It has more of a technical audience in mind and groundwater practitioners. So that again falls into the data or information tier that those who may not have the GIS or database resources to tap into our services or download the data. This view is really intended to be a hub to provide information and point you in the right direction to give you access to these data sets. It's under ongoing development, and recent additions that we'll also highlight are the addition of the State Board's Gamma water quality data, water year type data, as well as the statewide parcel data set, and a current conditions tab that was kind of a new thematic addition beyond the Sigma-oriented data tabs that we have on the left. So if I will I can switch over to my screen, Stephen, and then we can always go back if things don't work, as I'm hoping they will.
Okay, sounds great, Ben. Yep.
Okay, let me see if I can make the first step happen. So let me know when you can see my screen.
Okay, we can see it.
Okay.
And real quick, if anyone can't see it, just put a notice in the chat and we can respond to that. Thank you.
So again, Sigma Data View is one of our viewers that consume the services from the data sets that we showed earlier. And I'll go over some of the data sets that I mentioned earlier to see how they end up on the Sigma Data Viewer. There is a tour that kind of provides some guidance, some rough overview over the features and where to find the different query tools and how things function. It has conventional search bars to get you to your area of interest, and you can toggle your base maps. And then, other map features. But then also this little tour gives you an idea of the different data categories, the groundwater levels, groundwater storage, and some of the sample data sets that we'll go through fall into each one of these sections. And we'll also go over how to download some of the data. So I'll end this tour and dive into one of the data sets that I showed earlier on Open Data and the GIS services. And let's see if things load. So this is, again, the same data set. The map is having OK, here we go. So this map now shows the same GIS service that we showed earlier, and even more so, you can, when you zoom in far enough, you can select any of these stations, click on a site to bring up the water level data. You can select multiple stations from the map to superimpose those data, and then view the data on a chart in a table, and then also download the data set. Looking back at my notes, another way to download the data for a broader area of interest is you can use the search and download function, and you can either search by keyword, or you can select by area. In this case, I'll just specify a rectangle. You can apply a search buffer and search this data set, and then you'll get a table of the stations that the search returned, and then you can also download not just the stations list, but also the associated time series data into a zip file that will come with a README file. And this way you can access data for specific sites, but also, like we've shown, download data for smaller regional areas of interest. And again, if you want the whole data set, you can also go to Open Data and just go through the bulk download process. Quickly looking at my notes again, another data set that we showed on Open Data was the well completion reports data set, also shown on the Sigma Data Viewer. again, the historical legacy reports were often just indexed by the township range section, which are square mile areas. And often there's no better location information than just the centroid of those sections. And you'll see like a grid of those red dots. They represent well completion reports that have just been geocoded to their to the township range section square mile centroid. However, the yellow dots you'll see are well completion reports that have been located down to the specific site address, and you can select those to see the high level attributes, and then you can also click on a link of the PDF of the scan if it's a historical report. In some cases, those are fairly old, as you see here. And then again, of more recent well completion report submittals, you can bring up all the tabular data on open data for a specific well completion report by filtering each of the different resources. Then another layer that we mentioned earlier is the dry well reports layer. Maybe now is the time where things give up on me. It's stuck, so maybe now is the time where we have to switch back to you, Stephen, presenting. Oh, no, here we go. Okay, my internet connection came back to life. Can you still hear and see my screen?
Yep, we can see it.
Great. So here again, the map layer, same data as shown as on open data. We chose a symbology for to distinguish for older reports from more recent ones. In this case, red dots for reports coming in the last month, yellow last year, and then green earlier. And you can, again, select any of these records to find out any of the specific attributes that were provided. And now under a different category, under land subsidence, we'll explore that INSA layer as an example. We provide the raster data both for annual as well as in total. I'll pick the total raster again, statewide coverage through the medium high priority basins and more. So this is now for, you can select also your time period. So here, this is for the full current coverage that we currently have from June 2015 through October 2020. By the way, I think I forgot to mention earlier that the data set will be next updated towards the end of this year, beginning of next year, with data through October 2021. And then going forward, we'll have quarterly updates so that we don't have to wait a full year to get the data through the previous October. So you'll see the updates coming in 3-month intervals. So and on this map layer, you can select any location. And then to bring up the time series plot, you can click on the hyperlink. That may spin a bit. It's a very large data set, as you can imagine. And this is actually, again, pulling the time series data for this specific location using this Mosaic image service that I mentioned earlier. And if it doesn't pop up again, we may just switch back again, but I can also maybe just bring in, oh no, here we go. So here for this selected location, you see the time series data starting from June 2015 again, where statewide coverage started, all the way through October 2020, and soon this data set will be extended, like I said, by a whole year through October 2021. Our consultant teams are currently processing those data, and then again, to continue to improve our data services, we will then soon have quarterly updates. And again, this data can be downloaded as a CSV file, Excel file, and is annotated also by the lat longs for your records. My notes are telling me that I'm next going to talk about or mention the land use data that we showed earlier on the open data page. We also use the same services again that we make publicly available. And again, here's the 2018, 2016, and 2014 statewide crop mapping data sets, in addition to other more local mapping efforts. Again, very large data set. It'll take a while to load. So especially the first time if you access this page, be patient. And while this is loading, I will look what's up next. So again, I apologize for my internet connection. Again, what I wanted to show, maybe I'll just drag in my cheat sheet, is, no, I won't do that. Anyways, you'll see basically the same map that I showed earlier on the open data page will eventually pop up. And I believe with switching to 2018, the multi-cropping aspect and the attributes are available on the data table that we showed earlier. So hopefully things will load faster again for me. Now moving on to the next topic. Under water quality, what we mentioned earlier was our coordination with the state board to integrate the gamma water quality data. Previously, we had already added the DWR water quality stations, and we have since also added the gamma data set. Let's hope this is loading, otherwise Stephen, I would say, oh, here we go. So this highlights all the different source contributing programs to Gamma. And just to toggle to Gamma's water quality side, again, the state board's data is hosted on the state's open data page, not on the CNRA open data page. The way how you can find always the description and also the source data is if you click on these info icons that I should have mentioned earlier, and this brings up the Sigma Data Viewer docs to the corresponding section with the links also to the open data set and any other dedicated map applications that exist. And now on this data set, you can also select any of these stations, and it will include a link to the corresponding data set where the time series data are hosted. Let's see if I get lucky. And now it's pulling data from our open data page and shows you this was just sampled once, so we don't have a pretty chart, but you see the different constituents that are tabulated here. And then you can also filter what you want to show on the chart. And then going to the relatively recent addition of the current conditions tab, and that some of the development of those layers also then led into the concept of Cal Groundwater Live. So you'll see that some of these layers that were initially prepared for the current conditions tab on the Sigma Data Viewer were then also further utilized in Cal Groundwater Live. And vice versa, as Shane will later explain, some of the layers that were created for Cal Groundwater Live will also eventually be added back into this Sigma Data Viewer. So let me turn off the water quality layer so it's not too busy. And one of the additions was, and this is exactly the step from just looking at data and trying to make information of it. And let's see if this will load. I always keep threatening to go back to the presentation, but I was hopeful that things will load. It's loading now. So this takes the periodic groundwater level data set that we showed earlier, but rather than just giving you the whole data set to just stare at, we're trying to apply a process that the USGS applies to with a Groundwater Watch map application that they show to provide an idea of current conditions with a statistical percentiles analysis that kind of gives you an idea of how the most recent measurement compares to the statistical data for at least 10 years of data. And you can also filter this data set to just show wells that are at 25 percentile or below. And you can also apply a depth filter to, let's say, only show those wells that are screened in the, or have a depth range of, let's say, 300 feet. And then when you click on any of these wells, whoops, you can bring up the same hydrograph that we showed earlier, but also for those wells that these statistics were generated for, there's now a button that you can toggle to that will show you the statistical distribution of water level measurements for this month. And it will highlight the monthly median, and it will also highlight the most recent measurements where they fall within those distributions. And looking at my notes, one other addition that I hadn't mentioned earlier or shown earlier is with the addition of the water year type, you can now underlay water year type time series sourced from the Sigma data, Sigma water year type data set that is also open data, and then a different water year type data set that covers other areas. So in this case, it pulls it from the CDEC data set that predated the Sigma data set. So we didn't want to overlap data sets and create confusion. So depending on where you are, it'll pull the water year type data from the correct source. All right. And one more addition under the current conditions tab, we've already shown dry wells, so some of these layers appear under both current conditions and the correct category below. GPS stations also have been added under both current conditions as well as subsidence. And you'll see by default, these GPS stations are colored by the vertical displacement that they have measured over their individual period of record. And as with groundwater levels, you can also click on these sites and bring up the time series plot for those stations. This layer is a combination of networks from UNAVCO as well as SOPAC, and we kind of pre-process the data by applying a 31-day moving average that the others like the USGS also apply to kind of filter out the daily noise and to have a clearer picture of the more seasonal and then long-term changes too. Again, this data is then available through the download buttons. And one more example of a data layer that was recently added, this time under the boundaries tab, which is kind of a catch-all of all geographic reference layers, not just boundaries. But one data set that we recently added was a statewide parcels assessors layer that is publicly available and is available throughout the state. And it only includes the information of relevance to describing a location. The parcel APN, text APN format is slightly different. The street address, but it doesn't include any confidential information like owner information or tax information. But we wanted to stand up this service to help us improve the data location quality or the location data quality for incoming well completion reports and other groundwater data that we're collecting through our systems. And again, with the idea to better connect with other databases that are also parcel-based. And again, if you click on this info tab, you'll get the link to the GIS service that, again, you can use in your GIS software or in your online applications. And I believe that was it. I hope I stayed somewhat in my time, and we can turn to questions again.
All right. Well, thank you, Ben. I appreciate that. And it really shows the depth of and connections of how everything is really connected, and then how in the Sigma Data Viewer, there's a lot of options to explore information. And all of that architecture you talked about in the open data, and then went into then making the Sigma Data Viewer available to create, but that still has a lot of options, a lot of detail. And then the next segment of the webinar is going to be about how do we take that and generalize it for a more general audience, and then try and turn it into more knowledge or information on groundwater and the current status of groundwater conditions in California. All right, but before we go there, let's quickly touch on, let's pause for a question and answer session again. So we want to have this be a short pause, and then we have the longer Q&A at the very end that will answer all the remaining questions. So again, to put down or submit a question, please use the Microsoft Teams chat box if you're in Microsoft Teams. And if you're not in Microsoft Teams, you can email us a question at sgmps@water.ca.gov. All right, we'll bring Tim back in, and you want to let us know how we're doing on questions?
Yeah, no, we've had several excellent questions, so let's dive right in. So first question up is, how reliable are the subsidence data in the subsidence monitoring maps?
Yes, great question, and I did mention the data accuracy report on the open data dataset, and that analysis performed by Towel, a vendor that independently from the INSA vendor looked at how the INSA data compared to data from continuous GPS stations. And that statewide comparison resulted in a statistical difference that if you assume the GPS data to be a independent data set of higher accuracy, which is required for accuracy statement, they track within well within 0.1 feet. So I will try to bring out the report to get you the exact answer, but I would refer you to the open data dataset and the accuracy report by Towel for the specific numbers. And again, that accuracy statement is statewide for the entire dataset and all time steps. Depending on which region you may look at, the statistical difference between the continuous GPS stations or any other independent reference data that you may have may vary.
Great, thanks, Ben. Since you're up, I'll keep you going. Are some of the graphs and summary data shown on the Sigma Data Viewer available via API so we can build them into our own apps and services?
Yeah, so the widgets, basically those charting options, are themselves not available as the APIs that you could hit and then get a chart in response. At least they haven't been opened up, but that's a great comment, and that's one thing that we can look into, making some of these applications themselves reusable, and with that saving local agencies and public users the time and resources to having to reinvent those tools. Again, our first focus over the most recent years was to get our data sets out and to quickly stand up applications to allow interactions with those data and visualizations. But this is a great suggestion to make those tools reusable. But again, the data itself is accessible through APIs. So right now you would have to basically build your own application to visualize this, or again, just use the Sigma Data Viewer or other applications to explore those data.
And then Ben, this is Stephen, a real quick expansion of that question. So that was really geared towards the subsidence data. However, in other data, there are APIs. Could you touch on that really quick? Other data sets?
Yeah, so the data sets have the APIs. I understood the question if the actual charting tools would be an API, so that if you have a mapping application and you want to have a dynamic link where you then point to a pop-up, so that the pop-up and the chart that we would have, for example, in the Sigma Data Viewer, if those charts could be reused elsewhere. And so that the API wouldn't just return the data, but actually the chart. So if I understand the question correctly, then the answer is currently no, unless, Stephen, you can correct me if I'm wrong or forgetting something.
Okay, no, that sounds good. Okay, do we want to go to the next question?
Yeah, so a question regarding the Gamma dataset. Does the Gamma dataset also differentiate GPS location versus public land tract centroids, like the well completion reports did?
And that's a question that I'll be happy to relay to water board staff that is on the call. And I do want to highlight one thing is we presented several data sets that some of which SIGMO staff are data stewards for, but others are stewarded by other DWR programs, and in this case also the water boards. So if somebody else wants to take that question.
Yeah. Hey Ben, this is Aaron. So for those of you that don't know, I manage our Gamma database and the data that kind of comes in and out, day-to-day stuff. So technically, no, we don't have a way to determine that in the data. We like Ben just mentioned, are stewards of many other folks' data, and then we kind of standardize that. So unless there's a field that other folks provide to us or that we go out and get, we would have no indication that there is an actual location versus a centroid. But I can tell you, just from knowing the data in general, most of the wells are relatively accurately placed, I'd say, with the exception of a handful of results that we get from the water data library, water quality data portion from Department of Water Resources. A handful of those wells are in fact in the centroid, and you can see that when you query the data and look at it on the map. And then in addition to that, the DPR data set, those well results are not precise locations. They're within approximately a mile. But beyond that, most of the wells are reasonably close. So hope that helps.
Yeah, thank you, Aaron. Next question. Is there an option for live connection to the periodic or continuous groundwater level measurements?
Okay, so I am sharing my screen again. Can anyone see it?
Gotcha. See it.
Okay, so this is the open data set that we mentioned earlier, and again here the resources are a stations level, but also a resource or table of all the measurements, and it's live-ish. It gets updated, I believe, weekly, and if there's a need, so it was last updated a few days ago. And if there's a need, we can maybe entertain the thought also about updating those resources more frequently. But again, this data set can be filtered if you just want to view it through open data, or you can use the API for connections from your applications or queries to the underlying data set.
Great, thanks, Ben. Moving on, are there change notes available listing all of these new features or data sets in the data viewer?
I don't think that we have been doing as good of a job as we maybe can, and that may be good to also highlight in newsletters, maybe under in an area where people would look for any updates. So that's an area for improvement for us to highlight those differences, so you don't have to search for them. And also. Connected to this is like we really want to make sure that we build something that actually finds use, and sometimes some of these things are kind of a soft rollout because we're not quite sure if they really hit the target. So to respond, no, we probably don't make track changes as visible as we should, and the other comment is that being our user target group, please provide feedback on functionality that you would love to see, and any comments on improvements that we could make, and we'll add them to our list of things that we would like and prioritize them depending on how much feedback we get, how easy it is, how much resources it takes, and how many values these improvements would make. So thanks for the question, and we'll try to do a better job highlighting changes going forward.
Excellent. Thank you, Ben. And for our last question for this segment, it's one on the land use data set. And specifically, they're asking where does the vineyard acreage come from? Maybe you could speak a little bit to how those data sets are collected and validated as we post them.
Yeah, and again, here I want to make sure that I'm not the data steward for this data set, so I don't want to misspeak. I don't know if there are folks from that group on the call, but if you go to the dataset page, again, you can also find the contact emails of the data stewards. It is remotely sensed data, so the acreage that you would come up with any crop type is based on remote sensing as well as field verification by region office staff. And then I am also not sure which acreage. I don't think I showed a specific number, but again, this GIS layer can be used in your GIS processing software. So the acreage would be specific to your area that you're basically clipping this data set down to. So I'm not sure if I'm really nailing this answer, but again, refer to the data set documentation, reach out to the data stewards.
Yeah, and this is Stephen, just to build on Ben's answer there. Showing on the screen here is the data resources for the statewide crop mapping. And there is metadata associated with that. And there's a PDF file that you can read and see how the data is collected, what the accuracy is, and then also the consultant that we contract with, LandIQ, has additional information in there as well. So there's, and as Ben mentioned, there's the point of contact for the data steward from DWR that can provide additional information as well.
Great, thank you very much. That's the questions for this segment.
All right, so now we're going to turn it over to Brett Wyckoff and Shane Edmonds to then touch on the last segment of a new and upcoming California's Groundwater Live tool, which is part of our California's Groundwater Bulletin 118 effort. And so Brett's going to kick us off with giving an overview of California's Groundwater Bulletin 118, and then Shane's going to cover California's Groundwater Live.
Thank you, Stephen. Now I'm going to get into what Stephen was talking about a little earlier about how all this great data is used to produce new knowledge and information. And so this is something else that DWR does with this data, and that is to produce California's groundwater, which is also known as Bulletin 118. And a little bit of the background on California's groundwater is that it fulfills the statutory requirement, and DWR is required to report on California's groundwater conditions every 5 years. And then another item is that this serves as a summary of statewide groundwater information describing how groundwater occurs in California, how it's used and managed, different types of monitoring that we use, and then the conditions of groundwater in the state, and then coming up with a series of findings and recommendations based on that. And importantly, it also supports many actions, including the California's water resilience portfolio and drought response planning. And we also coordinate with the California Water Plan, which is produced by DWR and is the vision for water resource management in California. Next slide, please. And a little bit for those of you on the call who may be unaware of what's in California's groundwater update. It includes a highlights document. It's about 50 pages long, and it comes out in English and Spanish. And the highlights is, you can consider that to be an executive summary. It's a high-level summary of the most important information from the statewide content. And the most important part of that is it produces key findings and recommendations. And the statewide report contains several chapters on California's groundwater, including the background on California's groundwater, a discussion of currents of groundwater in California, and groundwater use estimations and well infrastructure, groundwater management, including SGMA implementation, and then discusses monitoring networks in the state, such as groundwater elevation and groundwater quality monitoring and subsidence monitoring, and then has a very detailed chapter in discussion of the groundwater conditions within the state and contains many analytics and graphics and maps to describe the conditions in the state. And then it wraps up with the hydrologic region summaries for each of the 10 hydrologic regions, the topics that are discussed in the statewide previous chapters are distilled down to the hydrologic region level, and we focus on each of those regions. And then with the topic of data, one thing we have done with this groundwater update is to make all the data that we have used to produce California's groundwater update. We've made that available on open data, and we've made all our appendices that support the document available online on the Cal Groundwater website. And then there's also, which Shane will be getting into in a little bit here, the California's Groundwater Live application, which is a way that DWR has endeavored to make data more available or more readily available to those who are interested in California's groundwater. One of the things, the reasons behind this is that with these 5-year reports that we produce, there is a data cutoff, and so we have to cut off at a certain date to produce the 5-year report. And so what we wanted to do was make the data that's used in producing California's groundwater updates more readily available, more on a real-time basis to interested parties, and, so that they don't have to wait for those 5-year reports to get the information they need. So with that, I'll turn it over to Shane, who's going to go into more in depth for California's Groundwater Live and give you a demo of that.
Yeah, good morning, everyone. So as Brett mentioned, as part of California's Groundwater, we have 3 pieces of online content. First, we have our California's Groundwater webpage. This is located on water.ca.gov, has information specifically about the bulletin that Brett had just mentioned. We also have a page on California Natural Resource Agency's Open Data Platform. This is the tool that Ben had showed quite a bit. We have a page dedicated to California's Groundwater Bulletin 118. It includes the actual documents that make up Update 2020. It includes the appendices as well as data that was used to create the document. And then the third piece of our online content, which is what we're going to focus on today, is an upcoming tool that we've developed called California's Groundwater Live. So what is California's Groundwater Live? So it's DWR's newest groundwater tool that we've developed. It was built using the same data sets as the other DWR applications. So earlier, Ben had showed the GIS services we have available. We had the Sigma Data Viewer. We have California's Groundwater Live, all kind of building. And the difference is the intended audience. So as Ben mentioned, beginning of the webinar, the GIS services is for the GIS expert, the technical user. They can plug into those services. They can have them live on their machine. The Sigma Data Viewer allows, an average user to view the data. And then California's Groundwater Live is intended to make creating customized data summaries and viewing the data easy for the general public or anyone who's interested in groundwater data. So we have a user-friendly design, and then importantly in 2021, it's actually mobile-friendly as well. So you can view the site on any tablet or smartphone. So the site itself, it consists of a website, and then we have supporting GIS story maps, and we have 10 interactive dashboards. We have data summaries that are called indicators, which provide high-level groundwater information. Below, these are examples of some indicators. This is a screenshot from the landing page that I'll show you guys in a few minutes. But basically, what this shows is on a statewide level, every time you upload or you go to the California's Groundwater Live page, these indicators will automatically query our groundwater level database based on the percentiles layer that Ben was talking about earlier, and it'll bin the latest groundwater levels into 3 bins as below normal, normal, or above normal, and instantly return it to your screen. As I mentioned before, the site also has interactive dashboards, and really the goal of the dashboards is to empower users to create whatever data summaries that you are interested in. So we have the ability with these dashboards. We have a left side panel here that we'll go over in a minute, but it allows the user to filter the data by different geographic areas like county or groundwater basin. A user can filter by well depth, by category, and even time period. You know, if you're interested in only seeing groundwater level measurements or well completion reports or land subsidence data for a certain time period, those dashboards allow you to create whatever data summaries you're interested in. So some of the other features, each of the dashboards includes an address lookup. So you can actually type in your address or the name of a city, and it'll automatically zoom the map to that area so you can orient yourself. Each one has a serial chart, which is basically a data summary of, you know, this is the data shown on the map, similar to what's shown in the Sigma Data Viewer. Each of the dashboards has a summary chart, so you can actually see, you know, how many dots are falling into each category, or, you know, how many wells or how many well completion reports fall into different categories. We have indicators down here. Indicators tell you total number of data points on the map. And then we have another indicator that tells you the total number of data points based on your selection. And then, like I mentioned before, we have this side panel that has various selectors in all the dashboards. So what content is included in California's Groundwater Live? So at this point, what we have built for California's Groundwater Live that will be released soon, there's 3 sections to the website. We have information on groundwater levels, well infrastructure, and land subsidence. So specifically for groundwater levels, we have 4 interactive dashboards that our team has built. We have one dedicated to current groundwater levels, one dedicated to groundwater level conditions, one for seasonal changes, which includes a 1, 3, 5, and 10-year change, as well as a 20-year trends dashboard. For well infrastructure, we have an interactive dashboard for domestic wells, irrigation wells, public supply wells, as well as dry well reporting. And then lastly, for subsidence, we have 2 dashboards that the team has developed, one dedicated to INSAR data and one dedicated to continuous GPS station data. So lastly, the website also includes an informational video that will tell you more about California's Groundwater Live. It'll include a series of user tutorials and then information about specifically how to access the data that you see in California's Groundwater Live. And as Ben mentioned earlier, some of the data sets that are included on California's Groundwater Live are not yet on the Sigma Data Viewer. The plan is eventually to get them all on there, but that link will give you information about how to access them. And also it includes a link to connect directly with our project team. So at the bottom of the page, I'll show you, we actually have a button where it'll be an auto-populated email that will come directly to myself and the rest of the project team. And we encourage folks on the webinar today, use this link, you know, once California's Groundwater Live is released, let us know what you think, other data sets that you think would be helpful, or additional functionality, as, you know, we envision this to be an ongoing process, adding data sets in the future, as well as adding functionality. So with that, we can transition to the demo. All right, so what we're looking at right here is the landing page for California's Groundwater Live. As I mentioned before, this is a tool that allows users to view, interact, and analyze the latest groundwater information, including current conditions, groundwater levels, well infrastructure, and land subsidence in an open and transparent platform. As I mentioned before, we have 2 different tools that have been built for California's Groundwater Live. The first tool are high-level data summaries called indicators. So here are the 3 indicators that we were looking at earlier. Every time you load California's Groundwater Live, these indicators will automatically query the data and return the latest summaries based on information that's been entered into DWR's groundwater databases. This is done automatically, so a user, anyone that accesses the site, all you have to do is basically type in the URL and you'll get these data summaries returned to you. So as we mentioned before, we're trying to make accessing groundwater data easier than ever before, and the series of indicators that we're showing here, and I'll scroll down and show you a few other ones, aim to do that with literally just a click of a button. So as I continue to scroll down the page, the first section of California's Groundwater Live, as I mentioned, is dedicated to groundwater levels. So we have 4 interactive dashboards. As I mentioned before, each of these icons that I'm scrolling over right now, if a user clicks on an icon, it will open up a new window and it will take them to the interactive dashboard. I'm going to continue scrolling down the page for now to show you the rest of that, and then we can look at the dashboards themselves. All right, so the next section is dedicated to well infrastructure. This section has information about domestic wells, irrigation wells, public supply wells, and reported dry wells. It has live indicators as well as the icons linking to the interactive dashboards. So these icons show the total number of well completion reports that have been submitted to DWR since 1977 is shown in the top of the indicator. The bottom number is the number of well completion reports received year to date. So we have that for both domestic wells and irrigation wells. This third indicator shows the total number of active public supply wells in the state. And this is based off of our friends over at the State Water Resources Control Board. They have a GIS feature service that we actually plugged into, and we are using their information. And then lastly, this indicator shows the total number of reports submitted to the dry well reporting system year to date, so in 2021, as well as the number of reports we've received within the last 30 days. Scrolling down to the bottom of California's Groundwater Live, we get to the land subsidence section. So this section includes a map showing the latest land subsidence in the state based on the INSAR data set for the most recent water year. It also includes 2 icons that lead to interactive dashboards, one for continuous GPS stations and one for INSAR data. The last thing I want to highlight on the page before we get into the interactive dashboards is the bottom ribbon here. We have an about page. If a user clicks this about page, it will take them to a new page where we have background information about California's Groundwater Live. That's where the informational video is housed, as well as the user tutorials. Here's the how to access data button. So if a user clicks this, it will navigate you to open data with a page that will link you with all the data sets that you see in their interactive dashboards and have information about how you can get plugged in to them. And then lastly, here's the link I mentioned earlier. This will create the auto-populated email that will connect with myself and the rest of the project team. So as I mentioned before, the second tool is interactive dashboards. So if you click on any of these icons, it will open a new window. And the new window will take you to an ArcGIS Online story map. So I'll quickly scroll up. This is the story map for groundwater levels. It includes 4 interactive dashboards. You can either get here, as I mentioned before, by clicking the icons on the home page, or you can actually use these navigation buttons up here to see the different dashboards. The first one we get to is current groundwater levels. So I'll show you a little bit of the functionality of these dashboards. One thing to note is if you press this button right here, it'll pop up your dashboard into a full screen view and a full window. So if you want to work with the dashboard and want it to fit full screen, I'd recommend doing that. You can also interact with it straight out of the story map like I'm going to do. So each dashboard includes an interactive map, which is shown here. Here's the address lookup feature I had shown earlier. So if you type in an address, I'll just type in Chico. it will zoom into that area, and you can see for this particular dashboard, you can see the current groundwater levels around Chico. Each of these represents a monitoring well. So if you click on one of the data points, a pop-up appears with more information. It actually will tell you the latest depth to water. So this particular well is 79 feet or so, around 80 feet. And it has a link here to Water Data Library. And if a user clicks this link, it'll actually open up a hydrograph for them. I'll try and do it, see if it loads here. Looks like it's working pretty good. So it'll give you more information about that particular monitoring well. And if you select this groundwater level data button, here's the hydrograph feature I was mentioning. So it is a pretty powerful tool. If you're curious what the groundwater level is in your area, you can use the address lookup feature, click on a few of the monitoring wells, and within a few minutes, you'll be able to tell whether the groundwater under your feet is 50 feet or 100 feet. The second thing I wanted to mention over here is this is called a serial chart. So these are all defaulting to a statewide setting. So this is statewide what groundwater level levels are. This is organized by depth to water. So if a user uses one of our selectors over here, the serial chart and the indicators will automatically update. So you can select, if you have county selected, let's say I want to know Los Angeles County. You can type in a county. The map will automatically zoom to that county. It will filter the data, which is what we're seeing here. It updated our serial chart, and it also updated this indicator based on the selector. So it gives you an idea of what's going on in your area of interest. To return to a statewide view, you simply click the reset button, and it'll return you to the statewide view of the map. All the data points are shown, and the serial chart and indicator will also reset. I'm going to scroll down to the next interactive dashboard, which is for groundwater level conditions. The thing I want to highlight on this dashboard, as we all know, it's a drought year this year. So this is what Ben had talked about. This is the same methodology used by the USGS for their WaterWatch website. It looks at the most recent groundwater level measurement and compares it to the last 10 years period of record. And then it bins it into different categories. So we have all-time low, below normal is these kind of reddish orange colors. Green represents normal, which is the middle 50th percentile. And then the blue and purple are above normal. So you can get a statewide view. As I said, looking at the dashboard by default, you can type in a county. Once again, we'll just type in Los Angeles as an example. And when a user types in a county for groundwater level conditions, you can quickly see that depending on what part of the state you're in, groundwater conditions can be a little bit different. So in this area, it looks like we have more wells in the normal range than we have statewide. Going back to the statewide view, one thing, if you're interested in knowing more about current groundwater level conditions, is you can use a category selector, which is what my mouse is scrolling on here. So if you want to know, I only want to know wells that are above normal, you can select those categories. I'll zoom out a little bit so it's easier to see. So I just selected the 3 above normal categories. It automatically updated the map. You can see where those wells are that are above normal, as well as the serial chart. And then you can see we got about, almost 300 out of 3,000 that are above normal. Or if you're interested in, below normal, you can use the same functionality, turning those layers on and off. So it's a pretty powerful tool. It's easy to use and gives you a easy way to kind of see what's going on. So continuing to scroll down, as I mentioned, we have our seasonal groundwater level changes dashboard. This particular dashboard is a data set that's included on the Sigma Data Viewer. I think the most powerful thing about this dashboard, looks like, okay, there we go, wasn't quite loaded yet, is we have seasonality built into this dashboard. So a user can select the season. So this is fall 2020. As fall measurements are coming in from GSAs throughout the state, this map will actually fill in over the next few weeks, hopefully. You can select spring or fall. So let's just do spring because we have more measurements. And then you can select the number of years change you want to see. So what we're defaulted to is a 1-year change. You can select a 3-year, a 5-year, and even a 10-year change. And you can see how wells have changed over those different time periods, as well as by season. Scrolling down to our last interactive dashboard for groundwater levels, it's 20-year groundwater level trends. So this is an analysis that was done for California's Groundwater Update 2020. It's looking at a statistical analysis of groundwater levels over the last 20 years. And then the analysis determines whether those wells have an increasing trend, a decreasing trend, or no statistical trend. And that's what we're looking at on this map. So we have about 4,000 wells that fit this criteria. Once again, we have the serial chart showing the statewide. We have the statewide results. We have the category selector. And then we also have, what I haven't shown yet is a well depth selector down here. So user can input any minimum and maximum depth into the well depth selector. And once again, it will update your map to only show wells that meet that depth. It'll update the serial chart as well as your indicator. So if you're interested in a certain aquifer as a GSA, or you're a well owner and you're curious about, what wells in my depth range have been doing over the last 20 years, you can use the well depth filter. And just to reiterate, the well depth filter is available on all of these dashboards, as well as the county selector and the category selector. I just decided to show one on each just so you guys would get a chance to see all of them. The next thing I want to show y'all quickly is our well infrastructure story map. So it's the same exact structure as the one we just looked at for groundwater levels, except for this one is dedicated to wells. The first dashboard is focused on domestic wells. It's based on the online system of well completion reports data set that Ben showed earlier. Has a lot of similar functionality. It includes each well completion report as an individual data set, data point. User can click. Has the same functionality, the link to the well completion report that Ben was showing earlier. The major difference is the summary, the ability to summarize the data. So this is a good one if you want to go, if you're a GSA or a county, and we'll just do Los Angeles because seems like that's the one we keep selecting today. So if I select Los Angeles County, this might take a minute because I haven't been on this dashboard yet. All right, let's see if it updates here. Okay, there it goes. It's a little bit slow. I think Ben and I have the same internet connection. But while this is loading, what you'll see is it'll zoom to the county. It'll show you the well completion reports in that county. Eventually, what this dashboard will do is it'll update. This is the well depth of those well completion reports. So it'll show you what the depth of wells in that county or that area are. It'll also show you the number that have been installed on an annual basis, which is what's in the upper right corner here. And then it'll show you the indicator, which will include the number of wells in that particular county. So it looks like this dashboard is not responding. So I will scroll down. I'll try to go to the next one. Hopefully we'll have better luck here. This is the irrigation well dashboard. Has the same functionality as the one I just went through, including the well completion report search, county basin selector. One of the things that I failed to mention in the last dashboard is it also includes a time period selector. So if you're interested, how many irrigation wells have been drilled in the state in the last 5 years, a user can select a time period. Well, looks like, let me try to reload and see if we can get a little more traction on here. Apologize for the technical difficulties. That's the joys of teleworking and variable connections. So we'll try and see if it works now. There we go. So I just selected the 5-year time period, and you can see it updated the indicator. So we've had about 8,000 irrigation wells over the last 5 years. It updated our well depth chart. You can see the depths of those irrigation wells, as well as the number installed each year. And if you zoom in on your map, you can actually see the locations of those wells that were drilled within the last 5 years. And you also have the ability, if you select the last 1 year, the map will filter and the serial charts and indicator will update. All right, the last interactive dashboard for wells we have developed right now is public supply wells. So this is once again showing public supply wells throughout the state. It's organized by public supply well type. So the Division of Drinking Water categorizes public supply wells into community, non-community, and non-transient, non-community type systems. And that's what's shown on the map. And once again, these are all the wells that are currently listed as active in the state. The last story map and dashboards I want to share with you guys before we wrap up the demo, I'm just going to refresh this one so we don't have the issues we had with the last one, is for land subsidence. So the first dashboard we have is for continuous GPS stations. This dashboard's a little unique compared to the other ones. It's got a little bit different functionality, but it's pretty slick. So what I'd recommend doing is it defaults to all the stations we have in the state, which is 345. You can select a station if you want. As you all can tell, these are not very good descriptions with the station names. So what we recommend doing is either zooming into an address lookup or using a county lookup. So I'm just going to type in Kings. And when a user selects a county, it will zoom to that county, and then it'll highlight the stations in that county. And then when a user selects a station, it'll highlight it on the map. And then it actually has a link to that station to show the elevation change. And then the user can choose whether they want to see the chart for the last 10 years, the last 5 years, the last year, or the entire period of record. So it's a pretty powerful tool. If you're interested in land subsidence, I know we had a question about that earlier, in a specific area, I'd recommend going to the continuous GPS interactive dashboard when it's available. You zoom into that area and you can actually look at the actual data and see how those elevations have changed over time. Oops. All right, the last interactive dashboard we have is dedicated to INSAR. So this is similar to what Ben had showed earlier. Same data set. The only real difference is, Ben, on the Sigma Data Viewer, you can choose 2 different dates. This one just defaults to water year. So if a user is interested in just seeing how subsidence has changed each year, you can just select different water years. The map will automatically update the serial chart and the indicator showing the total square miles in that particular year. So, and then the last thing before we end the demo, it's important to note is these 3 little dots up here with the lines. This is your legend on all of these interactive dashboards. So if you're looking at, this INSAR dashboard or any of the other ones, it's an important tool to push so you can actually see what the different colors represent. And then this button right here, you can select this, and there's a bunch of different base maps you can choose. So if you want to view a different base map, there's 20-ish or more that you can choose, and you have that ability. So with that, I think we can go ahead and end the demo of California's Groundwater Live and transition to the final question and answer session.
All right. Thank you, Shane. And we're excited about that tool and how it builds off of the other architecture and data sets that Ben mentioned earlier. Let me share my screen real quick here. And also on timeline, we are going through the final release logistics for the California's Groundwater Live, and we're shooting for sometime this month to get it out is really our goal. And that'll be widely known when it is live and available to the public. And we'll be putting various press releases and other information through our listservs and all of that. So just wanted to highlight that. So now looking at the final Q&A session, thank you all for hanging in there and staying with us this whole time. And we're looking for your feedback and additional questions that we have. And so again, if you have questions and you're logged into Microsoft Teams, put those in the chat box. And if you're not on Microsoft Teams, you can email your questions to sgmps@water.ca.gov. All right, so Tim, how are we looking at questions?
Yeah, absolutely. Thanks, Stephen. And thanks, Shane and Brett. That was an excellent presentation. Lots of information compiling this critical data to support groundwater management. So I want to acknowledge a comment that came in very early on in the discussion about accessibility and making sure that this data is available for our Spanish-speaking fellows, as well as other languages that really represent the diversity of California. So maybe we can speak a little bit as to how is the state providing groundwater data information in Spanish and other languages? Is there a plan for that?
Yeah, thank you, Tim. And that's a great comment. And I think there's another question that just came in about this as well. And so it's something we're striving for and we're working on. We're not all the way there yet, but in our work towards improving access to groundwater information, it's not just access to the data, but it's access to all of the communities that need groundwater information or want to see groundwater information. And so really where we've started in that effort to broaden the languages that we have this information in is, as Brett mentioned, California Groundwater Bulletin 118, that highlights document. It has more general information about California's groundwater and talks about the different data sets and conditions in the state, and also recommendations and findings. So it's not as detailed as what we've seen today with the different web applications, but it is one initial step in our process of increasing our access to groundwater information for Spanish-speaking communities. So that is something I'd highly recommend to check out. And then we are looking at other ways that we can make the dashboards and applications seen today more accessible to Spanish speakers in other languages. And so that's a work in progress. But I'd want to turn it over to my colleague, Melissa, and to touch on some of the other areas that we're trying to expand translation services and related to sustainable groundwater management and data.
Thanks, Stephen. This is Melissa Sparks-Kranz from DWR's Sustainable Groundwater Management Office. And just I want to touch on two other areas where we've been working to increase accessibility, is particularly in the space of translation. So the first one is as it relates to understanding groundwater data and information, the department, in coordination with the Water Board, has been tasked by the governor's first drought proclamation this year to create a framework that is really centered around how we're monitoring, analyzing, and minimizing impacts to communities that rely on groundwater for drinking water. And we've been leading this work over the last several months. And as part of that work, we hosted 5 public workshops over the last several months, and all of which we had live Spanish translation services in those workshops to really hear from communities in particular about how the drought and their experiences in the past and this summer have been impacting their drinking water supply if they're reliant on groundwater. And that information has resulted in a draft framework document that includes drinking water well principles and strategies. And we are moving to finalize that information and produce a final framework that really includes actions for the state to engage with communities around groundwater and drinking water. And so one of the pieces I just want to highlight is we do have a section of that framework document that's specific to groundwater data. And a lot of the information that we've shared today has been is connected to that overarching drinking water well principles and strategies framework. So we do encourage folks to review that document as well, and I'll share that in the chat in just a moment so you have access to that. We have the draft document that was released also available in Spanish. It's been translated. And then the other piece I wanted to touch on, the second item I wanted to touch on, is just the Department of Water Resources in our assistance capacity for locals implementing SGMA, the Sustainable Groundwater Management Act. We do provide written translation services to translate written information so that agencies can share that groundwater information with their communities. And we have, I believe, up to 8 different languages that we can support written translation. And so we strongly encourage that if you're a local agency, you contact us about those services to engage with your communities. And again, I will share that information in the chat as well so you have access to where to find that information.
Great. Thank you, Melissa and Stephen, for helping us with that. That's a great question and comment. As follow-up, a comment just came in, or question came in. At what point in time will there be sufficient information to calculate amount of existing groundwater plus amount of recharge minus 20 million acre feet equals balanced groundwater? How can we get to this understanding and analysis of balanced groundwater conditions, or ideally sustainable groundwater conditions?
Thank you, Tim. This is Stephen. I can take a first crack at this and welcome my colleagues' input. But this question is excellent, and it goes to the heart of what the Sustainable Groundwater Management Act is trying to accomplish in California, or create, is a better understanding of our groundwater resources, especially since they make up 40% of our water supply in normal years and up to 60% in drought years like we're facing now. And unlike surface water, we don't have that ability to see groundwater, like see reservoir levels, river levels. And so that is the fundamental question about SGMA and groundwater, and a lot of the work that has gone into making these data sets more available and accessible. I'd say we still have a ways to go to get that consistent across the state. However, there's been a tremendous amount of work done by the groundwater sustainability agencies, their teams, with input from local entities to get at what are the water budgets in these different groundwater basins, and that is part of their groundwater sustainability plans. So I would say that really starting and looking and engaging with the local groundwater sustainability agencies is important to answer this question, because they have been hard at work for a long time now to get at a better answer to that question. And then from the state perspective, we are working on a number of areas to have statewide modeling tools that our team is putting together. One example is for the entire Central Valley, which is called C2V Sim. And then there's other elements of understanding what is the aquifer structure. And Ben mentioned the work that our team is doing on airborne electromagnetic surveys that understand what the subsurface structure is, where the aquifers are, aquatards, and even basement in some areas. So all of that information is needed to understand what is the 3D physical structure of the aquifer, and then how does water move through that aquifer, and then how much water is used, how much water is recharged. So it's really at the crux of what we're all trying to tackle here as we continue to manage groundwater in the state. And I don't know if any of my colleagues would want to add to that.
Stephen, excellent response. Thank you. So I'm not seeing any additional questions or comments in the chat or in our email server. So Stephen, unless we have anything further, I think we can wrap.
All right. Well, I just want to start out by saying a huge thank you for everyone who attended today. As mentioned, this is recorded, so we'll have this to refer back to and watch on demand as needed. If your colleagues couldn't attend, or if you couldn't attend the entire time, so we'll have that resource. I'd also like to thank everyone that was part of the coordination committee for this effort, and then the presenters for putting the information together, and our teams within the department and the board and elsewhere that are making these data sets available, and the local agencies that are generating a tremendous amount of this data. And it just on that point, there are a lot of connections. This is scratching the surface of what's available within DWR, one portion of DWR. There are connections being made to local data management systems right now in SGMA that are very exciting, where local entities, GSAs, are taking this framework, but then putting it into the context of their basin and improving coordination in their basin. So it's really important to note that this isn't the one-stop shop. The tools that we shared today, it really is a source for authoritative information, and then that information can stream into whatever applications you all need to do the work that you're doing. And so with that, we wanted to end with just a list of links to the different programs, data sets, applications that we mentioned today, and then leaving you with contact information. So if you have additional feedback for us, our team at DWR or the board, we're really encouraging you to provide that, how today's webinar went, but also general feedback on Cal Groundwater Live when it comes out, SGMA Data Viewer, and other ideas you have on data sets that are needed in the state of California, or tools to interpret that data. So with that, we can close it out, and thank you and have a great rest of the day, and hopefully the rain continues on. So thanks.